Take a look at this area on the fender that's rusted through. So there are pinholes through this fender. Stick around in this video if you want to see those holes disappear into this. Today I thought we'd play with another welder by Andeli. This one is a multifunction MIG, stick, a plasma cutter, a TIG welder, and it has a cleaning function, I think, for stainless steel. So I have one of their helmets. Here are all the accessories that come in the kit. This is an extra liner for the MIG torch. This right here is a cleaning torch. It has a little brush on the end for cleaning stainless. Extra hose, air hose. This is the MIG torch, nice and comfortable. Some plasma cutting consumables. This is the stick clamp. More air connections, gas connections, some extra TIG parts. And then here's the plasma cutter. So I thought we would take it out of the box and just put it through its paces. I do have a small project. Well, it's probably not even that small. This is a fender from a 69 to 73 long hood. This is what I have on my car Mac, which I can show you guys under the cover. But this is the long hood style, which has these signal boxes that extend down. I remade this on my car. I didn't have these fenders at the time. But I do want to take some measurements off this fender, which is one of the reasons why I have it. But what I thought we'd do today is take a look at this area on the fender that's rusted through. So there are pinholes through this fender, and it looks like someone's done some welding on it in the past. Typically this section rots out because the way it mounts to the car, there's a cavity behind here. Let's flip it over. This is the flange that connects to the car. There's a similar flange and uses bolts to attach the fender to the car. So the rust bubbles are right about here on the opposite side. So below here is a cavity that often rusts and gets debris or water caught in it. Usually the water filters down to this end, and then there usually is an open drain here, and it's sort of supposed to drain, but once you get dirt and debris and leaves in there, it just clogs up and basically ends up rusting the whole fender. So somebody has repaired this in the past. The way the fender actually is supposed to roll around, it's supposed to roll around and crimp onto this feature. Right now, the metal is overlapping in a weird way that's just not correct. This is how that underside is supposed to look. This gets hemmed over or crimped over this part. So this has a relief to it. Then it separates, it looks like, into two pieces here. This piece belongs to this, and then it's got a little hole detent here to, I think, provide some stiffness to this part. But you can see how it has a relief and an area where this hem can fold over the inner structure. And then the outer skin is just spot welded in a few places along here. So this is a good example of how it should look. Most likely we have to remove this inner structure to repair the outer skin. The rest of the fender doesn't look too bad. This piece often gets rusty. The headlight bucket often gets rusty too. Rust is just starting to form in this primered area. But the actual headlight bucket, I mean, it doesn't look horrible. I don't know if someone fixed this already, but we can put a headline in and find out. But anyways, that's kind of today's project. I don't need this for my car, but I do want to demonstrate some of the features of the welder. Before I cut into this, I'm going to remove some of this primer and see what it's like underneath. This is a strip it disc, which is a low RPM Makita sander. It strips it pretty quick. Okay, I didn't find too much Bondo, but it's pretty evident that the overlap section is rusty all the way out to like right here. That's what I'm thinking. Not treated correctly. This is where those holes are. So it wasn't primed on the backside. It was just kind of seam sealed. And so it just continued to rust. Right here is more of the same. This is seam sealer. Which, you know, whatever primer they used comes right off. This skin is just welded right onto this. That's typical when you see little holes like this. It's always way worse underneath the structure. So that's what I'm saying. This outer skin can be patched. The inner structure needs to be completely removed, repaired or replaced, and then it needs to be painted correctly before you try to pinch it back together. I forgot to say this previously, but normally I would have taken a contour gauge and created a template for this feature, but because it has been messed with before, I don't really trust the shape it was before. So what I will do is I'll either take a template off my car or the other fender and do a reverse. So this shape was all buckled in the center. There wasn't any point in templating that because I know it's wrong. This is pretty much only held together with seam sealer. So what we found is what probably was a rust hole right here has just been completely gobbed over and ground down. And then it's got a seam weld here on the edge. So that's why I was unable to just break it free with this thing. So we're gonna have to probably cut right here and also just cut around this. Pretty gross, huh? So I'm not really sure what this strip of metal was for. It's got holes in it. Probably, you know, held it together with screws and then they just welded it. So it's really, really too bad. This is it. It was pretty unpredictable where it was attached because there's all these extra welds that normally aren't there. So I was a little more rough with it than usual. But one thing I noticed right away is there's no depression here like the driver's side had. And I guess that is probably for the antenna. Maybe that's where the antenna would go through. So this piece is maybe salvageable, you know, maybe not. I don't know. That's the factory seam we saw on the driver's side. Here's that little relief, you know. It's just, the weird thing is it looks better on this side than it does on this side because this was just completely filled up with Bondo, which I don't know who puts Bondo on the inside other than, you know, someone who was trying to hide a repair. Very weird. I tried to preserve this angle with the factory sheet metal rather than just cutting it all off right here. I wanted to kind of have something to go from. This metal here looks like it's okay. I wrinkled it a little bit. This metal here is all extra. So the idea here is to fill up this giant hole we made, and then we can tip this flange after it's welded in. A little bit rusty right here, so I may elect to take a little bit more out of this corner. It needs to be tuned up because the way I cut it, it's got some sharp edges, so we want a nice smooth contour. Here's a carbide burr to take off some of those sharp edges. There is a nice good metal to weld to. No sharp corners. This one was deepened a little bit to avoid the rust on the back side, but that's about as sharp as you should go. You don't want a sharp corner because it makes metal finishing even harder. But yeah, this is now ready to trace and create the patch panel. You can use just about anything to trace, but this shipping paper kind of has a nice gentle curve to it because it comes off a roll. So now that this paper is kind of fixed, I can feel where the cut is. And so if I just run my finger over this, it creates a little impression in the paper. So So because the paper is a little bit bunched up, it's fitting really well right here. This has a new edge based on the way it bunched up. So let me tape this down. Just going to refold this. So the metal is just below that paper. With the exception of this corner right here, it's a little bunched up, but it's pretty close. Close enough to transfer this to metal now. The last thing to decide on is what metal thickness to use. So let's measure how thick this thing is. 35. We'll measure in a few places. 30, 35. Here's a bare sheet of 20 gauge. 20 gauge measures 035, 034. 18 gauge, which is the next size up. This one measures 45. Yeah, 45. So this 18 gauge is probably a little too thick. I think I'm gonna go with 20. So when I transfer this shape to the 20 gauge, I need to allow for a little bit of material to hang over. That is one, because it's easier to weld when there's extra material on the ends, and two, because we need to, create a new contour and hem this around its inner structure. If the paper's too thin, you can just scribble across it. This is ultimately gonna get a contour, but for now, I'm just doing something like that, which is gonna be plenty of material, because the actual body line is gonna be between these 2 points. It's gonna snake in like that. We're left with the blue line. And the nice thing about the scribbles is it tells you which side of the line we need to trim on. We want to trim right up to the blue. We want to trim on this side of the line. So let's use the Andeli in cut mode. That's it. So now we have the plasma cutter set up with the machine. Just got to check the polarity settings on the ground clamp. So right now the ground clamp is set to the positive terminal. Okay, I just checked the manual and this is correct. The ground clamp, which is this cable attached to the table, goes to the positive. This one goes nowhere. You need leave it loose. So with the machine on, we need to push this button until we get to the cutting tool. And we have, up to 50 amps available for cutting. So this thin metal only really needs, I don't know, the minimum's 20. Let's just try 31. Okay, purely freehand, and I really didn't want to overheat the metal and burn off the ink, but it didn't heat it much at all. In fact, the cut is really clean. There's very little dross on this section where I was going a good speed. Here I was going a little too slow, and there is a little bit of the dross, but that clips right off, and we're gonna cut this again with the snips. Let me show you. The reason why this combo is so effective is because as these shears or snips cut the material, it needs to have a waste side. And if there's too much material on the waste side, it can bunch up the piece you want to keep. So I like to do the plasma cutter as a rough cut. Our cut shape is looking pretty close. Most of the curvature is here at the top, so just getting it started. So the rough shape is pretty much following the contour of the fender. We got to work on the gaps a little bit. This is way too big right here. It's sitting a little proud. But yeah, it's fitting okay. So I've drilled some opposing holes here to help hold this part in place. Using these clecos and pliers should allow me to just tab that thing in there. So since I've spent time fine-tuning the gap on this side, this is going to help hold it while I fine-tune the gap on that side. I did leave it a little bit long right here because I'm anticipating a little shrinkage when we get down to this area. So what I'll do is, I mean, I can snap this in there. I mean, it will go in, but because it's going to shrink, I want to leave it a little long here. I can always trim that in a little bit. I've been experimenting with this Andeli welder in its cold mode, cold weld mode. And what that does is it does like a real quick tack. It uses like a 10 hertz frequency pulse. And yeah, there's a couple settings you can set it to. You can set the time in which it's on and off. You can set the current and you can set the frequency. So I think I found a good setting here. It is at 118 milliseconds, 70 amps, and 10 hertz. And that gives me pretty good penetration on both sides with a tack weld. So I'm going to do that right here to the fender and hope it holds. I'm just going to wipe off some of that ink with it's acetone. So I got a little too close at the end, but let me show you what that did. That time I didn't touch the tungsten, and it's working really well. So right here you can see how this section's still a little bit long. So it fits pretty well right till about here, and then it basically just need to lift it up and just grind this top piece. I have a little trace line on there. I don't know if it's visible in the camera, but in addition to the Andeli welder, I'm using the Andeli helmet, and it's really nice, works well. It's got a little smaller viewing area than my other one, but it has this LED feature. So when it gets the welding light, it shuts off. But when it's dark, like with my hand over it here, it's on. So that helps you, line up your torch, get your tungsten height right, get your filler ready, and then it'll turn off when you're actually welding. Super cool. It has the typical settings on the side. I'm set to number 9 because this is pretty thin metal. We're only going to be welding at like 30 amps max. So I like that. You can change the sensitivity, the delay. You can do all kinds of stuff with it. So that fits really nice now that we did that last. This part of this panel here is a little bit low, partly because of this previous weld. So what I do is I'll just tack it in where it fits well, where the clamp is, and then we'll massage these later. Once I know it'll go together. The cut is right. It's just a matter of prioritizing what fits well, and then we'll fix what doesn't fit well. Everything is really flush right now. So the only thing that's left is right here. This is the largest gap. So that's probably the thickness of the metal. It's basically a gap of about 30 thousandths, because that's what the filler wire is. So I'm gonna tack this one in with conventional welding just to make sure that it's gonna bridge both sides. Because the spot welding feature, the cold welding feature has to have something to weld. If there's air between there, it won't do it. There's actually a better look at the gap now that it's clamped. So just a tiny little bit right there. Okay, so there's the tacks on there. Notice how the blue zone is much larger. So this is the cold welding, is a lot less heat. I guess that's why they call it cold welding. For about the same length of weld, this is a much larger heat affected zone. So it just causes a little bit more distortion, but you know, this had to be done here because of the gap. It's really flush everywhere along the whole thing, all the way down to this side. So it's ready to just do all the final welding. I'm just gonna rattle off the settings real quick. This is on high frequency TIG, 28 amps. I may increase it a little bit once I get going, but 28 amps to start with. The filler wire is 030. This is just a straightened MIG wire. And the gas flow rate, you can't tell right now, but it's set to 15 when the gas is flowing, and this is argon. The helmet shade is on 9. It's as low as it'll go. And then there is no amperage control on this device. It just has on off, which I'm not really used to that, but I'm gonna do it anyways. Just gonna stop and check the penetration on the back. Yeah, the penetration back here looks good. I can see a little bead on the bottom. Could add maybe just a little bit more filler, so I'll make that change and just keep going. You can see these balloon areas, the start and stops. I tried to minimize the start and stops, but sometimes I had to reposition my hands. So there's one, there's another one, but this is really nicely welded, worked great. So for these holes, I've switched, these are 1/8 inch holes by the way, and I've switched to a larger filler. This is 16th inch filler, which I guess is 060 versus, so it's twice as big as the previous filler. And we need to be careful with these because it's on off. So we got to hit it and then back off quick. The holes are gone. So what I'm seeing, I'm already starting to see some of the distortion now. Basically, this corner is dipped down, and that's why I don't do sharp corners, because it would dip even worse. Ideally, this would have been a little bit more round like that, but remember there was rust underneath there, so I extended this corner up. So this has a depression, and then it's slightly low here in the middle. So like right here, it's fine. That's where the previous weld was. Right here, it feels fine. There's a lot of structure right here in this bend. For me, the biggest difference with the Andeli welder that I'm used to is the finger control. So this is just an on-off switch. You can hear it clicking. That's all it does. And the reason why it's different, I'm typically welding with a foot pedal. And that just allows me to hold the torch a little bit more precise. I usually hold it up here, but I can't do that with this. I have to hold it with the finger thing. That's why I've dipped the tungsten a couple times. I'm just getting used to the finger control, but you absolutely can do this with on-off. The cold welding feature was great in getting the weld started. So when you provide full power to the seam, it's pretty easy for it to erode the edges. And the way the cold weld feature works is this has high frequency start. So it shoots a really focused lightning bolt right at the seam. That gets the arc stabilized right in the middle. So if you have a sharp tungsten and you have the distance real tight, the metal has no choice but to bond together. I found that it worked really well. I'd say 9 times out of 10, it bonded it perfectly together. The only time it didn't bond was if there's a little air gap in there. If that's the case, then you have to have a little filler handy, and you could either lay it on top of the seam and zap it in there with the cold weld, or you can add filler as you go. I thought it worked great. Once the weld is started, it's pretty easy to go full power on top of the existing weld and just carry it along the fender. We're not gonna go over the MIG functions of this welder. I've done an Andeli video with the MIG functions previously. That works fine. We don't really need it for this fender. We got the holes filled up. The one thing that MIG is good for auto body, and one of the reasons why you should consider a multi-function welder, is that when you do plug welds, like here where we drilled holes, that's gonna have to be overlapped metal. You typically drill a hole in the upper one, and then you fill that hole with a rosette weld, and that's best done with a MIG welder. So it's great that we can do cutting, we can do welding, and we can do filling with the MIG welder. It's pretty much all you ever need in auto body or any car fabrication for that point. I don't need a fender for my car. This is just a demo for you guys. It's a demo for Andeli. I do get a commission if you decide to buy it, but I'm just here to test out new stuff and share with you guys some of the tips on how to get these panels to fit, all that stuff. So yeah, that's kind of all I can say about the welder. It's great. There's really no excuse not to pick up one of these inverter style welders. They're so inexpensive now. It's 3 or 4 welders in one, and you just got to get one and practice. That's the name of the game. Here's the back side of the weld. Not much grinding needed on this side. It does penetrate all the way through, and the width of that heat affected zone, this is in inches. So 0.7, 0.8. The widest is probably, I don't know, right here. The widest is 0.9. The faster you travel, the narrower the heat affected zone is. This is 20 gauge, so it was really hard to travel super fast, but I did my best. So for metal finishing, what I like to do is I like to start with this thing. This is not a conventional grinder by any means, it's a cutoff wheel. But if there's anything that's proud, like some of these start-stop points, I'll take the very tops off. Here's a little bead right there that's pretty proud. So I'll just knock those down real quick with this without grinding into either side of the metal. I'm only touching the weld here. And then I'll come back with this 2-inch 40 grit or 60 grit, and that's gonna knock it completely smooth, and then we can hammer the distortions out. There's only grinding on top of the weld, not on either side of the metal. So that's what I've done here. It's pretty smooth now. The thing you gotta be careful of is this is a valley now because of the distortion. So if you just try to grind it flat, you gotta be careful because it's inside a valley. So I like to just start with that wheel. Obviously, the wheel being round can get inside the valley. And then I'm gonna come back now and just take off what is just called the roots of the weld. I'm gonna try to blend it in as best as possible, but leave it just a little bit proud. And then I'm gonna use the hammer to kind of even it out too. I'm gonna hammer it after I grind it as smooth as possible. Super light pressure. Same thing, I'm not holding the disc flat, I'm just using the edge of it. Might be kind of glary with this headlight, but I've got the welds down probably 80% of what they need to be, and that's with a really coarse disc. So now I'm gonna do the hammering, and it's kind of mush this metal into a flatter surface. And there's not much metal to mush because it's, like I said, about 80% ground down. So once we take the valley out of this and get this thing perfectly flat, it'll be much easier then to do the final grind and make it almost invisible. What I'm doing is I'm putting pressure on the bottom and I'm hitting this with the hammer. This is a pretty high crown area on the hammer. So I'm only hammering the welds within that blue zone. And I want to hear that dinging sound, because what that's doing is it's undoing the shrinking that the weld caused. This is stretching it. When the metal gets pinched between these two hard surfaces, it stretches it out. You know, it's pretty flat. I think right here is a slight depression right there. I think I'm done hammering for a while. So all the distortion has been removed. It's a little bit wonky right here, but you know, if you're just, it's hard to show this in the video, but just by feel, it feels like a Fender. There's no obvious ripples and weird stuff. So now I'm gonna switch to the 120 grit disc and go ahead and now feather this out just a little bit. It's pretty smooth right now, especially after the hammering. This is typically about as far as I take it. So you could spend infinitely more time on this. To be honest, the DA sander hides a lot of sins. You could put die chem on this and then use a steel file, body file, and it'll reveal all the highs and lows, and you can sit there for hours and raise and lower sections that are, you know, deviated. But this is, for the most part, what I would consider done. This would need like just a tiny bit of filler. Most people just are happy to use a filler. I can guarantee you the filler would be less than the thickness of that ruler. So remember we put this on the surface? So any daylight underneath there would be filler, but they're essentially, you know, there really isn't there's hardly any daylight anywhere. Maybe like a tiny bit right there. And I did spend a lot of time hammering this corner. The corners are typically the hardest to deal with, because it shrinks this way and it shrinks this way, and then it kind of puckers this down. That's always the hardest. That's why there's a little bit more hammer marks in this region. But in general, I think this came out great. The next step would be to hem this flange over. So let me know if you guys want to see more of this. This is not for my car. This is just kind of for funsies and to really demonstrate the Andeli welder. But if you guys are interested, I can go through and make this a usable fender again. The bending of this flange is tricky. It's in 3 dimensions. It's not just a linear bend, so that is gonna require a lot of metalworking, and it's gonna require the oxyacetylene torch to get that flange to bend. So I don't know, if you guys are interested in that, let me know. I would also need to replace the inner structure with something better, or maybe repair the old one, but I don't know. I don't know if it's worth putting that much time and effort into this project when I have other things I should be doing. But let me know what you guys think, and we'll see you next week. Cheers.